In today's MATLAB video, we are going to be discussing operators, special characters, number formats, and data types. Let's start with operators. Operators are symbols in MATLAB that execute a certain operation. So we have different types of operators. Let's start with arithmetic operators. So these are, for example, addition, subtraction, multiplication, division, and so on. The addition operator, 3 plus 4, adds numbers together to give us 7. The subtraction operator subtracts numbers, so 3 minus 4 is negative 1. The multiplication operator multiplies numbers, so 3 times 4 is 12. And the division operator divides numbers, so 3 divided by 4 is 0.75. Relational operators is the next one. The first relational operator that I'm going to talk about is the EQ operator. This operator uses a double equal sign to check whether two expressions are equal to each other. This is not the same as a single equal sign. A single equal sign is called an assignment operator because, for example, if we say x equals 4, we are assigning the value of 4 to the variable x. So when we assign values to variables, we use a single equal sign, which is the assignment operator. But with this double equal sign, we are actually comparing two expressions a and b to determine whether they are equal. So it is the equality operator. So for example, say I have a equals 5 and b equals 2. If I now use the equality operator for a equal to b, this will now check whether the two expressions are equal to each other. So that means it will check whether 5 equals 2. And it does not. But MATLAB is not going to give you a yes or no answer. It is instead going to give you zeros and ones. 0 and 1 are called Boolean values. Boolean values are true or false. So 0 means false and 1 means true. And MATLAB will output either 0 or 1 to indicate true or false. So is the statement true or is it false? Well, A does not equal B because 5 does not equal 2. So MATLAB output a 0. You can also use the syntax EQ 5, 2, which is going to be A, B. Your first number is A and your second number is B. These are the two numbers you're comparing, so I guess it doesn't really matter which order you put it in. And it will give you the same answer of 0. So you can do it either this way or you can do it this way. We can also compare sets of numbers. So for example, if I have a set of numbers 1, 2, 3, and 4 for A, then I have 2, 2, 4, 4 for B. So now if I do A equals B, MATLAB is going to compare the two sets of numbers. But how does it compare a set of numbers with one another? It will actually compare the first value in both sets, then the second value in both sets, and so on. So it's trying to see if these numbers are equal to each other. And if they are, MATLAB will give you a true statement in the output, and that will be a 1. Let's check the first positions. The first position in the set of numbers for A is 1, and the first position in the set of numbers for B is 2. 1 does not equal 2, so that's false. So MATLAB will give you a 0 in this first position when you type in A equals B. Then we check the second number. The second number here is 2, and the second number here is 2, and they equal one another. So MATLAB gives you a 1 for true. Yes, they equal. Then we do the same thing with the third number and the fourth number. So you will see that the third numbers 3 and 4 do not equal each other, so MATLAB put a 0. And the last numbers in each set equal one another because they're both 4, so MATLAB will give you a 1 for true. They are equal. Then we can use the NE operator. This checks for inequality. So it's the opposite of what we just did. So for example, my A and my B are going to stay as they are. This is going to check for inequality, so it will check whether two numbers are not equal to one another. If the two numbers are not equal, then MATLAB will give you a 1, which means true. But if the numbers are equal, then MATLAB will give you a 0. If this is confusing, then I would just look at the equality operator and think of the opposite answer for this one. So if I'm trying to compare again these vectors a and b, the not equal to or inequality operator, instead of a double equals sign, we use the squiggly line and one equal sign, and we say a does not equal b. We have 1, 0, 1, 0. When we did a equals b, we had 0, 1, 0, 1. So that means the answers are reversed with this operator. And we can also put NE, a comma b, and a and b are going to be our vectors that we made up here. So we will get the same answer. So you can do it both ways. So what MATLAB is doing is asking itself, are these numbers not equal? So remember, if we have sets of vectors like this, MATLAB is going to compare the first number in each set. 1 and 2, they are not equal. So that's true. It will put a 1. Then the next numbers, 2 and 2, are equal. So it will give a 0. And so on for the rest of the numbers. If we just had two values, like a is 5 and b is 2, it would just compare those values. Now they are not equal to each other, so we should get a 1, which means true, they're not equal, rather than a 0 like we did for a is equal to b. Now we check the greater than operator. Say I have a equals 5 and b equals 2 again. If I want to check whether a is greater than b, I do a, and we use the same symbol that we use with math when we're dealing with inequalities, and we get the answer 1. Well, remember, MATLAB only gives answers as 1 or 0, which means true or false. So 5 is greater than b. So a is greater than b because 5 is greater than 2. And that statement is true, so MATLAB gives you a 1. Now if I want to check less than, if I say a less than b, well, a is 5, and it is actually greater than b, which is 2. So this statement should be false. And if I hit enter, that's correct. I get a 0, which means the statement is false. Now if I want to check greater than or equal to, if a was 2 and b was 2, then a would be greater than or equal to b. But a is 5, so it is way greater than b. So if I do a is greater than b, it should still give me 1. And if I check less than or equal to, and I do a is less than b, it should give me 0 because this statement is false. Now let's check the last type of operator, which are logical operators. The first one is the AND operator. This will compare expressions to determine whether the values are non-zero. The AND operator takes two different values and puts them together to check whether they're true or false. So if I do this with two values, again, a equals 5 and b equals 2, and I put a and b, what that does is give me 1. MATLAB is asking itself, are both a and b non-zero values? And they are. So we get a 1, which means that statement is true. We could write it like this as well, so we have and a comma b, and we also get a 1. Now we check the OR operator. MATLAB is checking whether either one of these numbers is a non-zero value. Both of them are, but if even one of them is, then we get a true statement. So the OR operator is a straight line, a or b. And we should get a 1 because MATLAB is asking itself, is either a or b a non-zero value? And both of them are non-zero, so that statement is true. We can also have OR a comma b. Next we have the NOT operator. This does not compare two values, but it checks whether the value that you put in is 0 or not. If you have a non-zero value, MATLAB will output a 0. If you have a 0, MATLAB will output a 1. So for example, if I have a equals 5, and I put not of a, and you can also use the squiggly line of a, you will get 0 in both cases. This is because MATLAB is checking whether a is 0 or if it is a non-zero value. Because a is 5, it's a non-zero value, so MATLAB will give us 0. Now we also have the double and the double OR operator. These are called shortcut operators. So putting these in your code stop MATLAB from evaluating an expression fully. So usually we use the shortcut operators when we are comparing single scalar values. So I'll show you an example. And we use the single operator and or when we are comparing sets of data, arrays. So for example, here's where I'll use the double operator. Suppose I wanted to check whether A is equal to B and whether B is equal to C. So the answer is 0, which means false, because this statement is not true. A does not equal B and B does not equal C. Now say we check whether A equals B or whether B equals B. The answer is 1, because at least one of these statements is true. It's that B is equal to B. Now say I wanted to check whether A equals B and B equals B. I get a 0. These shortcut operators, the double and the double or, are usually used when we have scalar values, just single numbers like A equals 5 and B equals 4, that we're comparing. And when we use the single and or the single or operator, that's usually when we have arrays or sets of data. Now let's try using the XOR. So this is not an operator, it's a function, but it seems fitting to add it into this lesson, so I did. This is the exclusive OR function, so the syntax for this is XOR A comma B. What this is doing XOR of A, which is 5, and B, which is 2. And it's comparing them and checking whether only one variable, but not both, are non-zero. So if that statement is true, we will get a 1 in the output. The reason we got a 0 here is because we don't have any variables that are non-zero. We need at least and only one 0 in order to make this statement true. Now let's talk about special characters. So this picture is a list of some of MATLAB's special characters. So we don't really use these in equations, but they are usually used in plots, such as axes, labels, and titles. So for example, say I have a vector A, 1, 2, 3, 4, 5, and then I have B, also 1, 2, 3, 4, 5. I haven't got to plotting yet, but I'll plot it just for the sake of showing you how to do this. In my title, I put, this is a graph of alpha and gamma. I need to include the backslashes just like they show in the table. And now if I hit enter, alpha and gamma, these Greek letters, are showing up here in my title rather than the words alpha or gamma. So that is how you would use the special characters. Now let's talk about number formatting. Say I have the number pi. If I type pi into MATLAB, it gives me 3.1416. So I'm inserting this table here, and this shows all the different styles for formatting. These are built-in commands. So if I type the format that I want here, it will turn purple once I type the words, and everything after that, all the numbers after that, will be in that certain format. So for example, let's take a look at format long. Now if I type pi after format long, look at how many decimal places are after it. Or any other number that I type, it would keep many, many decimal places, actually up to 15 decimal places after the decimal. We can do scientific notation. So if I have format short e, then I put pi, it puts it into scientific notation. And there are many other styles on that chart that you can take a look at. There is also one that gives you whether a number is positive or negative. It's not really a style of giving the answer with the decimal place. So for example, if I put pi, the answer is positive, but if I have negative pi, that would be a negative number. So to convert between different number formats, all you have to do is just write a new format out and everything you type will be changed after that. Now let's talk about data types. So in computing, a data type, also just called type, is a characteristic of the data that you are entering into the program. This tells the computer how to interpret and use the data that you're entering. So every value that you enter into MATLAB has a certain data type associated with it. And we can also convert between these data types. So let's check out the first one. We have numeric types. A numeric data type is the data type that stores numerical values. And these can be stored in different formats. For example, if I type in double 32, I get 32. Let's go through some of the common numeric data types. I've inserted this table here. So double, the first element in the table, is by default how MATLAB will store numeric values. And these are stored as double precision floating point values. Double precision is also sometimes just called double, which is the first numeric data type in the table. This is just a format that gives more accurate precision for numerical calculations compared to single precision. And a side note on floating point, because computer memory is limited, we cannot store numbers with infinite precision. So for example, if I have 0.33333 plus 0.33333 plus 0.33333, I would get 1. I know MATLAB rounded here to 1, but technically a computer would see this as 0.99999 going on forever. So when do you cut the decimal off? To fix this issue, computers use arithmetic called floating point, and they're usually in the form of scientific notation. So that was just a little aside on floating point, but by default, MATLAB stores numbers as a double precision floating point. And you can't change the default, but you can convert numeric data types between one another. You might be wondering, why do we have so many different numeric data types? Well, I've inserted this table here. So there are different ranges of values that would be more appropriate to use with different data types. So this is the same as the table I had inserted earlier, but in that extra middle column, it gives a clearer picture of which range of values we need to use with each numeric data type. Note also where it says signed and unsigned integers, that signed integers are ones that can be both positive and negative, and unsigned integers can only be 0 or positive. However, they can also represent larger positive values than signed integers can. Now, for example, let's look at storing the number 325.499 as a 16-bit signed integer. So we are going to use the command 16int, and in the brackets we have to put the number that we want to store as a 16-bit signed integer. When I hit enter, it goes to 325. So now the numeric data type is a 16-bit signed integer. To convert between numeric types, we can use the following commands in the table. So say we have the vector a, -5 to 5. Now I use the cast function. You'll notice when you write commands, a yellow box might pop up, and that shows you what you need to put in the brackets. So the first thing that you would need in your brackets is the number that you're trying to change the data type of, which is our vector a, and then you need in single quotes the numeric type you're trying to change it to. So we have uint8. So we are going to change this vector into an unsigned 8-bit integer, and the command for it is uint8 from the tables that I had posted earlier. And so this is what comes up. We have 0, 5 as our new vector. But why is it 0, 5? Well, if you go back to this table that I had posted earlier, look at the range of values for an unsigned 8-bit integer. It is only from 0 up until 2 to the 8 minus 1. 2 to the 8 is 256, minus 1 is 255. So the numeric type unsigned 8-bit integer is appropriate for storing values from 0 until 255. That does not include -5. So that is why this was changed to 0, which is the lowest value that it can take on. Now, there are many other different data types, but let's talk about categorical arrays. These store sets of qualitative data. So this qualitative data is non-numeric because it's qualitative and not quantitative, and it's discrete, so there would have to be separate categories. For example, if we look at categories of pets, to create a categorical data type, we need curly brackets, and we need to list the different elements within our category in single quotes. When you put single quotes, you'll notice that words will turn purple in MATLAB. The first pet in the category is dog. Then we have to separate it by a space and put single quotes around the next pet, which is a cat. Then we again separate it by a space and put fish. Now when we hit enter, we have dog, cat, fish in our category. So now to change this to a categorical array, the variable that is storing these pets is ands. So I'm going to use the categorical command and do categorical of ands. So now these are stored as a categorical array data type because we just converted this into the categorical array. So if you type class of ands, which is now our new variable, you will get categorical. That tells you the data type. But if we had made this to begin with and then typed class of our variable ands, it would be cell. So note that we had to do this step to change it into the categorical data type because otherwise it would just be a cell data type. There are a lot of other data types that I will not go into in depth, but if you'd like to check them out, click the link in the description below. Now, to determine the data type of a variable, we need to use the command class of x, where x is the value we are checking the data type of. Just like we did it here, and we found out that the class or data type for this string was actually cell. Now, for example, say I have a equals 5, and I check the class of 5, it's double. This tells me that it is stored as that double precision floating point that I mentioned earlier, which is a numeric data type. If I, for instance, wrote the word dog, now I can check the class, and it would be char, which means character. It is the character data type. You can use class to tell you what data type something is, but you can also specifically check whether you have certain data types, such as, is my input a cell array, or is it a character array, or is it a numerical array? Here's a list of different commands that you can use to check whether a certain data type is what you think it is. So for example, if I want to check whether I have a character array, but for example, if I have vector 1, 2, 3, 4, 5, and I want to check if it's a character array, well, it shouldn't be because it's numbers. It should be a numeric data type. And if I type class of A, it tells me it's double, which is one of our numeric data types. But to specifically check whether it's a character array, I can look at that table and type in is_char of A. And I get 0, which means A is not a character array data type, because 0 means false or not true in MATLAB. So what if I wanted to convert it into 1? What if I didn't want MATLAB to read this as a matrix? I wanted MATLAB to read this as text instead. Here's a table of commands to help you convert between data types. Now, if I wanted to convert my matrix 1, 2, 3, 4, 5 into a string, I will do int to stir and put the matrix right in here. So now I have this. Let's check if it's a character array. And I got 1, which means yes, I have converted it into a string. So that's all I wanted to talk about today. If you have any questions, leave them in the comments below. Check out the link in the description below for a more detailed blog post on today's lesson. Thanks for watching.